Hi everybody, today we are going to learn a new process which is called rationalizing the denominator. So in our math class we have a rule, and that rule is that we will never leave our final answer with a square root in the denominator of our fraction like you see here. So we have a process that helps us get rid of this square root, and that process is called rationalizing the denominator. So this is just to make sure our final answer is simplified. So how it works is you look at the square root that is left inside your denominator, and you're actually going to multiply the numerator and the denominator by whatever that square root is. So remember, if we're multiplying a fraction, we have to multiply the same thing to the top and the bottom. So let's see what happens when we do this. So 1 times square root of 5 is square root of 5. And then here, if we have square root of 5 times the square root of 5, this actually becomes the square root of 25, because when we are multiplying square roots, if two numbers are on the inside, we can multiply them together, and then we can simplify that from there. We know that 25 is a perfect square, so it just becomes 5. So it's okay to have a square root in the numerator of our answer, but it's never okay to leave it in the denominator. So by doing this process of rationalizing, it should make your square root disappear, because you should always end up with a perfect square. So this is actually what our final answer looks like. And just note that we can't divide these two numbers because this is a square root and this is not. Okay, so let's see if we can do this process on these 4 examples. So on this first one, we have 1 over the square root of 6. So I see that I need to multiply the numerator and denominator by square root of 6 over square root of 6. Same thing on the top and the bottom. So this gives us 1 times the square root of 6 divided by the square root of 36, which is a perfect square. So we get square root of 6 over 6. Square root of 36 is just 6. And this is our final simplified answer. Okay, let's try this one. 3 over square root of 7. So we need to go and multiply the numerator and denominator by square root of 7. So 3 times the square root of 7 is just 3 square root of 7 divided by the square root of 49. And we know that that's a perfect square. Square root of 49 is 7. So this is our final answer. Let's try example C. So remember, our only goal is to clear the square root. So we don't need to actually worry about the 2. We just need to worry about the square root of 3. So I'm going to multiply the numerator and denominator by square root of 3 over square root of 3. So 5 times square root of 3 is just 5 square root of 3. Here we have 2 times the square root of 9. So remember, we can only multiply numbers that are both square roots. So 3 times 3 is 9. And then we can simplify. 2 times square root of 9 is 3. So our final answer ends up being 5 times the square root of 3 over 6. So we just kind of go through the process. So remember, square root of 3 times square root of 3 is square root of 9. And since it's a perfect square, square root of 9 is just 3. So our final answer, again, is 5 times the square root of 3 over 6. And last one here. So there's a few different ways you can approach this problem, but one thing you do need to note is that the square root of 8 can actually be simplified. So usually it makes it a little easier if we simplify our square roots first. So remember, the way we do that is with a little factor tree. So we find our prime factors, we list them underneath our square root sign, we circle our pairs, and for each pair, one number escapes to the front. So if I have the simplified version, I'm left with this, okay? And then I see that we have a square root left in our denominator. So I'm going to multiply the numerator and the denominator by square root of 2. So we have 4 times the square root of 2 over 2, that's this 2, and square root of 2 times square root of 2 is square root of 4, which of course is a perfect square. The square root of 4 is 2, And then it's just a little bit more simplifying. We end up with 4 root 2 over 4, and we know that 4 divided by 4 is just 1, so our answer is just square root of 2. So you do need to make sure that you simplify all the way. This is the process of rationalizing, so that gets rid of the square root sign, but you still need to make sure that you simplify it because at the end of the day, it's still a fraction. Okay, go ahead and try these last 4 problems, and then we'll check our answers, and then we're all done. Okay, let's check our answers really quick. So the first one, multiply by square root of 11 over square root of 11. Your final answer should be square root of 11 over 11. For part B, we multiply by root 2 over root 2. So we get 5 root 2 over 2 because the square root of 4 is just 2. For part C, remember we only multiply by the square root. We don't worry about the 5. So we multiply by root 6 over root 6. We end up with 2 root 6 over 5 times 6. And of course 5 times 6 is 30. And if you notice, we have a 2 and a 30. Both of those can be divided by 2. So we end up with root 6 over 15. 30 divided by 2 is 15. Okay, and for this last one here, this one is the trickiest one probably. We first need to simplify the square root of 12, which becomes 2 times the square root of 3. So I just rewrote it. Then I multiplied the numerator and denominator by root 3 over 3 to rationalize. So here we get 2 times root 3 over 2 times square root of 9, which is 3. 2 times 3 is 6. And here, 2 over 6 we can simplify to 1 over 3. So our final answer is root 3 over 3. All right, that's all for tonight. Thank you so much for watching.